Okay, we're in a new chapter, chapter 6, where this deals with um, rational exponents and also radical functions. In 6.1, we're going to evaluate what is called the nth roots and use rational exponents. So generally, what they're going to call this is that we're trying to find the nth root where b to the n power equals a. This is where b is what is considered the nth root, and if b to the n power equals a, we can make the assumption that b would equal the nth root of a. So if we're looking for real nth roots, first thing we have to do is determine whether n is even or odd. If it's even, we must write our conclusions with plus or minus in mind. If it is odd, we don't have to necessarily do the plus or minus. We can just solve accordingly. So let's say for these examples, I have n equals 3 and a equals negative 216. So if I, use the b to the n equals a situation, I'm going to substitute in n in for 3 and a is my negative 216. So using the assumption that a to the n equals a and also b equals the nth root of a, so that means that if this is b cubed, that means I have to take the third root to get my b. And the third root of 216, if you were to punch this into your calculator, it would look something kind of like this. Let me get rid of. So if I were to go negative 216 to the, now if I'm looking for the third root, that means you're going to use the fraction 1 divided by 3. And it equals negative 6. Okay? So for b, same thing applies. So I'm going to say b to the fourth power equals 81. Here I'm going to take the fourth root because it's to the fourth power. And b equals, now because our exponent of n is even, I have to say plus or minus. And this is 3. So the fourth root of 81 is 3. This kind of validates the point that I was making earlier. So if you let a to the 1 over n be the nth root of a and let m be the positive integer, we can say that a divided by m equals 1 over n times m, which also equals the nth root of a times m. It's kind of what I was talking about when I was punching in my calculator. But if here it says evaluate rational expressions without using it, but I'll use it just for demonstration purposes. So if I go 49 to the 3 divided by 2 power ends up equaling 343. If we take a look at b, I have 16 to the 7 divided by 4 power. That equals 128. And then the last one is negative 1 to the 10 divided by 3. And that equals 1. Not too bad. Here, again, we're going to evaluate these expressions, and I'm going to round them to the nearest hundredth. So if I have in parentheses negative 84 to the parentheses 2 divided by 3 power, it gets me 19.18. Here, I can rewrite this as 8 to the 2 over 4 power because my numerator tells me about powers, or how much I'm going to, square it by in this case. And then the denominator tells me what root I'm going to take it as, and this happens to be the fourth root. But I can make that fraction the lowest terms and say that it is 1/2. So if I take, say if I take 8 to the 1/2 power, it's 2.83. So let me show you something. So let's just say, for instance, I was going to take the fourth root of 8. So so the fourth root of 8 would actually be 1 divided by 4. And then I'm going to square it. I should get the same value. And I do. I get the same value here. Oh, shoot. I get the same value here as I do here. So the answer is 2.8, or 2.83. Here, punch in the calculator. If I go negative 16 to the negative 4 divided by 5. So that's 0.11. Okay. Last thing is we're going to ask to solve equations using the nth root. So approximate to the nearest hundredth if necessary. So here, I want to get the variable by itself, so I'm going to divide both sides by 6, which gives me x cubed equals 64. And since it's cubed, I'm going to take the third root. And so this leaves me with x, and the third root of 64 is 4. Okay. Looking at b, again, I want to isolate my squares, or my exponents, so that gives me minus 3 to both sides. So now I have x minus 7, quantity to the fourth, equals 81. Now I need to take the fourth root of this, both sides, which on the left side just gives me x minus 7 equals, so now since that root is even, it's plus or minus, and the fourth root of 81 is 3. So now solving for x, I have to break this down into two equations. X minus 7 equals 3, and x minus 7 equals negative 3. Here my x here will equal 10, and here my x will equal a negative 4. Last example is, get some space here. Need to solve for x. So first off, I'm going to subtract both sides by 8. So now I got 9x to the fourth equals 30. Divide both sides by 9, which gives me x to the fourth equals, well, 30 divided by 9 can be reduced to 10 over 3 by taking the fourth root to both sides. My x here will equal plus or minus, because it's an even n, and the fourth root of 10 thirds to the nearest hundredth would be roughly 1.35. And that is evaluating the nth root and using rational exponents. Hope this helps. Till next time.